Okay, so the goal for this example is to make a connection with exponential functions. So we learned before that an exponential function has the form f of x equals a times b to the x. And guys, in this old note now, we know that a is going to be your starting value. So we talked about that quite a bit. And then your b is going to be your, in this case, your multiply or divide pattern. So it's a pattern where we multiply or divide. So it's multiply or divide. So we had that from before. Now what we want to do is, since we now know more about exponents, let's practice evaluating different things. So in this function here, f of x, it equals to 4 times 2 to the x. If I want to find f of negative 2, remember all that means is the f tells me which function to work with. So I'm going to work with this one. And then this negative 2 represents my input or my x, what I want to check to see in my function. So here we go. F of negative 2 in this example means take your function and write this again. So 4 parentheses 2. And then in place of this x, I want to check what it's worth when I input a negative 2 in place of that. So I'll put that here now. And guys, we now know from today's notes that when we have a negative exponent, a positive exponent represents a list of repeated multiplication. A negative exponent represents a list of repeated division. So when we see this kind of work here, what this is saying to us is I'm going to divide here by 2 times. It's a list. So this means to divide by 2 2's. But using our actual idea from today's notes, if I think of it this way, I can take this, and notice how in this case this negative 2 applies to just a 2. To make this negative 2 positive, I can move it down to the bottom, so I get 2 squared. And this 4 stays on top because this is not part of this exponent. So now what I get is I get 4 divided by 2 squared here is going to be 4 also. So 4 divided by 4 equals to 1. So what I find is that f of negative 2 equals to 1. And guys, again, all this means in fancy notation is that when x is 2, y is negative 1. So on the table, when x is negative 2, that's here, y, or the function, is going to output a positive 1. Now to go back to the actual exponential function that we already know, here the a value is 4, so your starting value is going to be 4. So I can write that down here. So what that means is at x equals to 0, we start at y is 4. So we can add that in also. And we know in this function from before that the b here is 2 and the b's are pattern. So in this case, we're going to have a times 2 pattern going down the table. So watch. 1 times 2 is going to be 2. 2 times 2, notice we'll get our 4. Then 4 times 2, we'll get 8. And if we go backwards in this table, we can just do divide by 2. So 1 divided by 2 will give us 1/2. And guys, sorry, this is like a 5. This is meant to be an arrow. Sorry about that. This is an arrow going backwards. So to finish this example, we have our completed table with our starting value of 4 and our pattern of times 2. In this case, because the b number is 2, remember from before that when the b is more than 1, we know how multiplying works. It's going to make this 4 get bigger and bigger and bigger. See how it gets bigger and bigger and bigger. So it's going to be a growth function. And because b is 2, its growth factor is 2, as a percent change, that's when we have to describe how much more is our b number from 1. And so it's 1 more than 1. So because it's 1 more than 1, it's 100% growth. Guys, to finish here, lastly, let's go ahead and plot these points. So if I plot these points, because I know it's going to be an exponential growth function, I expect the curve going upwards in some ways, but I have the specific points. So negative 3/2 is going to be negative 3/2 is about there. And then I have the point negative 2, 1. That's going to be negative 2, 1 is here. And then I have negative 1, 2. So negative 1, 2 is going to be here. Notice how in the beginning it doesn't really grow too fast, but watch the next couple of points. 0, 4 is going to be 0, 4. Do you see how there it got a little bit bigger? So you can see the curves are in the form. And then to finish, 1, 8 is going to be 1, 8. And here it gets much bigger. So if I kind of put these together, I can see my curve taking shape.